We're going to do some practice with Le Chatelier's principle. This little chart right here is really good to kind of give you an idea of what's going to happen. It generalizes everything. You can look through it and basically see what it tells you. I'm not going to sit here and go through every single piece of this, but we are going to do some practice problems. So if we go to the first one, our first practice problem, if I move my face, is this equation right here. So we're just going to look at each one of these things. So for A, it says if we decrease the concentration of dihydrogen sulfide, well, that's this right here. So if we take this out, what's going to happen is it's going to need to make more of it. So the way it's going to do this is it's going to shift to the left, or you could say shift reverse. For B, to increase the pressure on the system. That works for this one because it's all gases. And remember that the idea of the pressure is the more molecules of gas that you have, the more the pressure. Well, if I get my pointer options going here. On this side, I have 1 molecule of CH4 and 2 molecules of H2S. So there's 3 total molecules on that side. There's 1 molecule of CS2 and 4, so that's a total of 5 on the right-hand side. There's going to be more pressure with 5, and there's going to be less pressure with 3. So now we look back at the problem, and it says if I increase the pressure, well, we always know to do the opposite. So if you increase the pressure, you're going to want to decrease the pressure in response. So the decreased pressure side would be the left, so it's going to shift left or shift reverse. We increase the temperature on the system. I can't answer that with this equation as it's written because temperature isn't written in here. I would need to see the kilojoules of heat. So really for this one, it's not applicable. Like we can't do that. There's a really bad A for you. If we increase the concentration of carbon disulfide, that would be this one right here, carbon disulfide. So if we make more of CS2, the answer here is going to be to make less of it, and how you make less of it is to move away from it. So it would shift to the left or shift reverse in order to get rid of this, because if you go to the right, you make more. Decrease the concentration of methane. Well, methane in this case is CH4. We're looking at this one. So if we take this out, the answer is going to be to make more of it. Well, you make more CH4 when you go to the left. So yet again, the answer is going to be shift left or shift reverse. Moving on to a different equation, if we look at our first one here, if sulfur dioxide is added to the system, well, that's this one right here, SO2. If we put more of this in, then we need to move away from it. So we're going to shift to the left or shift reverse in order to get rid of it. Sulfur trioxide is removed from the system. Well, now we're looking at the double underlined one. That's SO3. So if we take this out, you're going to want to make more. And how you make more is you shift to the left or you shift reverse. If oxygen is added to the system, well, that's O2. So if O2 is added to the system, you are going to want to use it up and basically make less of it. So how you use it up is you shift to the left or you shift reverse. I hadn't tried all these before this, so it's kind of weird that they're all working out with an answer of shift left or shift reverse. Hopefully some of my other problems won't do that. This one says predict the effect. It's the same idea, like we're answering the same question. What's going to happen to the equilibrium? We're still answering shift left or shift right, forward, reverse. It's just a differently worded question, and that throws some of you off. These I can do some heat changes. So the thing is for every single one of them, we're looking at decreasing the temperature, the effects of decreasing the temperature. So if I decrease the temperature of this first equation, well, remember if the temperature is on the right, it's making heat, it's producing heat if it goes to the right, and it's going to be using heat if it goes to the left. So if we decrease temperature, the opposite of decreasing the temperature is increasing the temperature, making more temp. So the answer for this one is that it would shift to the right because it needs to produce more heat. So finally, we have one that shifts to the right. With B, the difference with this one is it's not written in the equation, and you're actually going to have to know how to write in the equation. This is a positive 32, so you would first have to know that it would be written, I said 32, it says 37. It's a positive 37.2 kilojoules. and I'm not good writing with the mouse. Maybe one day I'll get a pen. It's going to be written just like this one. It's going to go on the right-hand side because it's positive. I'm sorry, I said that totally backwards. So you get to watch me make a mistake as I do this. Actually, because it's positive, it's going to be written over here on the left-hand side. I'm still not fully up to my amount of sleep after a sick kid. So let's get this straight. Okay, now, oops. We write it on the left-hand side because it's positive. That means it's going in. It's being added to it. And so if we decrease the temperature of this reaction on B, you're going to need to make more heat. Well, if you go to the right, you're using up the heat. You're not making any more of it. So it's going to have to shift to the left or shift reverse on this one in order to produce more kilojoules of heat. Now, on this one, your sleep-deprived teacher is going to get it right this time. And we're going to put the 27.6 over here on the right-hand side because it is a negative, which means it's exothermic. It is coming out of the reaction. And you write it based on the standard equation, and standard is written with the arrow pointing to the right. So 27.6 kilojoules will come out every time you're producing CO2 and H2. So if we decrease the temperature of the equation in C, we need to make more temperature. And how you make more temperature is produce more heat. So it would need to proceed to the right. And I believe I have one last example here. I think this is the last one. What would happen to the position, so same question, of the equilibrium? Will it shift right, shift left, reverse, forward, when the following changes are made? So if we add HGO to this system, that's right here, if we add more of this, then we need to move away from it. So it's going to shift to the right in order to use it up and make something else. So the answer to A is shift right or shift forward. For B, if the pressure on the system increases, well, the only thing that doesn't work with this, and how we're going to do this for my classes, is we're not going to answer this basically because there's a solid and a liquid. Like, we aren't dealing with a completely gaseous equilibrium. You could answer it that if there's a gas over here, there'd be more pressure on the right and less pressure on the left. So you could answer it that it would shift left, but for my classes, I won't ask you this. You'll only be asked one that has gases all the way across to deal with it, just because that's how we're going to roll. And let's see, that was my last example. If you have any questions about why the answers are what they are, or if your sleep-deprived teacher has totally screwed something else up and doesn't realize it, either email me or respond to the video and put a comment underneath it, and I will do my best to fix it. Thanks for sticking with my rambling.